Welcome to the Explainer. Today, we're looking at the powerful AI tools many of us are using to write and fix code. They feel like magic. But what happens when the magic is a little unpredictable?
We're diving into a paper that puts this unpredictability under the microscope. It's titled Analyzing the Instability of Large Language Models in Automated Bug Injection and Correction by researchers Ilhan, and Corinne. They ask a simple but crucial question. Can we rely on an AI to give us the same correct fix every time?
Exactly. I mean, think about it. You've got a bug, you ask your AI assistant for a fix. Great, it gives you one. But what if you asked it again? Would you even get the same answer? Well, these researchers found that a lot of the time, you just won't. Okay, so this slide really shows the core puzzle, right? On the screen, you see two different fixes for the exact same bug, and they were both generated by the same AI. This is the whole phenomenon they call instability.
That's it, exactly. In technical terms, it's called non-determinism. It basically means the same input doesn't always lead to the same output. Now, that can be a really cool feature for creativity, but when it comes to reliability in software engineering, it's a potential nightmare.
All right, so to figure out just how deep this problem goes, the researchers designed a really rigorous experiment. They decided to systematically test the popular GPT-4 model. So what they did was they took 20 known buggy code snippets from a standard benchmark. It's called QuicksBugs. And for each and every one of those bugs, they prompted GPT-4 to fix it 9 separate times, just to see what would happen. Okay, so they didn't just ask 9 times, they also tweaked a really key setting called temperature, right? Theo, can you break that down for us? What exactly is that?
Yeah, for sure. The easiest way to think of temperature is like a creativity knob. A low temperature, say 0, tells the AI to be super conservative and just give the most obvious, most probable answer. But a high temperature, like 1, tells it to be more creative, take more risks, and that leads to way more varied responses. So for this experiment, they tested temperatures of 0, 0.5, and 1.
Okay, so now they've got this big pile of different code fixes. How in the world did they compare them?
Right, so they used 2 main metrics. The first one is up on the screen now, Vivensheen distance, which measures syntactic similarity. And in simple terms, it just analyzes how different the code looks on a character-by-character basis. Does it have the same words in the same order?
But of course, code that looks totally different can still do the exact same thing, right? So the second, and I'd say more important metric, was the output equivalence rate, or OER. This measures functional equivalence. Basically, it answers the big question, does the code actually work and pass all the tests, no matter how it's written? Okay, so let me see if I've got this straight. They took a bug, they asked GPT-4 to fix it 9 times with these different creativity settings, and then they checked if the fixes look the same and, most importantly, if they all actually worked. Okay, I'm ready. Let's dive into what they found. Well, the results revealed a really clear and direct trade-off. It turns out, the more creative the AI was encouraged to be, the less reliable it became. Okay, first, let's just look at syntactic similarity. And this is even at the lowest temperature setting. For some simple problems like K-teeth, yeah, the AI produced pretty much identical code every single time. But, and this is the key part, for more complex problems like bucket sort or breadth first search, the solutions were structurally very different from each other right from the get-go. Right, so the code looks different. But here's the million-dollar question, does it still work?
And that's where this trade-off becomes really stark. Let's look at the functional success rate, the OER.
And this chart just brilliantly illustrates the core finding. Look at this. At temperature 0, the most deterministic, boring setting, the overall success rate was a solid 70%. But as they turned up that creativity knob to 1.0, look what happens. The success rate plummets to just 62%. More creativity literally led to more failures. Wow. So at the highest creativity setting, the AI was failing almost half the time. That is a huge deal if you're actually relying on it for a critical bug fix in your code.
Exactly. This slide shows it perfectly. At temperature 1, that failed category suddenly becomes the single largest group of outcomes. It's more likely to fail than to succeed.
But honestly, here's the most crucial point in the whole paper. You might be thinking, okay, simple. The solution is just to set the temperature to 0 all the time. But the researchers found that even at this quote-unquote safest setting, the model still wasn't perfectly consistent.
Wait, hold on. So even when you tell the AI to be as predictable and boring as possible, it's still a bit of a wild card?
Precisely. For 35% of the problems, the model failed at temperature 0. It seems like some level of this non-determinism is just baked into how these models work. It's not just a function of the creativity setting. Okay, so the big takeaway here isn't that these tools are useless, but that we really need to be much, much smarter about how we use them. So what do the researchers suggest we actually do about this? Well, they propose a protocol for working with these LLMs more safely. And it's pretty straightforward. Instead of just accepting the first answer, generate several. Then use automated tests to verify which ones actually work. And for automated systems, like in a CI/CD pipeline, you can even set a rule that an AI's fix is only accepted if, say, 3 out of 5 of the generated solutions all pass the test suite. Yeah, so the crucial point is to treat the AI less like some perfect, all-knowing oracle and more like a very fast, sometimes brilliant, but occasionally unreliable junior developer. You absolutely still need to check its work. So we started with this puzzle, right? Why is our AI coding assistant sometimes so inconsistent? And it turns out that the AI's creativity and its reliability are in this constant, tricky tug of war.
Yeah, and the findings don't diminish how powerful these tools are, not at all. But they really highlight the need for us, the users, to build a process of verification and trust. This instability, it's real, and it shouldn't be overlooked.
And that really leaves us with a final thought to consider for the future. Thank you so much for joining us for this explainer. Thanks for listening.